Hello, this is Buffers Lesson 2, Video 2, Weak Base Buffer Systems. So for this, if we have a base plus water, we know that our generic equation is going to be this. So a base plus water, water acts as the acid and donates a proton to the base, and we get BH plus, and then we get OH minus, and this is where we would get our POH value and pH from. So this is our generic equation. So if this is NH3 plus water, we get NH4 plus and OH minus. Now we're going to look at what happens if we add a strong acid and a strong base. And they're basically the same explanations that we did before. So I'm going to skip all that and just go over the net reaction. I'm not as concerned if you know which way it shifts and all that, but just a net reaction is going to occur. So if we have H3O plus and our base, this gives us this equation for our net reaction. So this right here is our weak base. This is our added acid. This is our salt. We add a strong base. Here is our net reaction. So this is our added base. This is our salt. This is our weak base. So these are the two things that we're going to look at if we have a weak base buffer system. So our example problem says find the pH before and after the addition of 0.0500 molar HCl to a buffer solution made from 0.120 molar NH3 and 0.180 molar NH4Br. And I gave you a Kb value. That tells us, along with NH3, which is ammonia, we look on our pink chart, that lets us know that we have a weak base buffer system. So this is a weak base buffer. So we know that before we add anything, we can use the Henderson-Hasselbalch equation, and we're going to have to use the base form, which is POH equals PKB plus the log of the concentration of salt over concentration of base. So in this case, here's our Kb. If you take the negative log of that, we get 4.74 plus the log of the salt concentration. Well, NH4Br is the salt. How do I know this? I know that this is a weak base. Sometimes you just have to recognize NH3 is always going to be a weak base. The other substance has the NH4 and Br. So if this is a base, the NH4 part of it is our common ion. So we have 0.180 over concentration of our base. So when you put this in a calculator, if you're not getting the same answers that I am, do the math inside the parentheses and then take the log of that answer and then add it to 4.74. And you should get a POH of 4.92 and a pH, which is 14 minus that, of 9.08. So there is one of our answers. That is before the addition of HCl. HCl is a strong acid. So we have to use the correct net reaction. So HCl is a strong acid, so we're going to use this net reaction up here. So for part B, we have to write our net reaction. And our ice chart. So the H3O initially that we have is 0.0500 molar. Our base was 0.120 and our salt was 0.180. Whatever we add in this case, the 0.0500 molar HCl is going to get used up. So this goes down by this amount, and so does the base. But then on the other side of the arrow, the salt goes up by that amount. So now all we have to do is calculate our values. So this is approximately 0. The base becomes 0.0700, and the salt becomes 0.230. So now we can use these two values to plug back in here to our POH Henderson-Hasselbalch equation. Our pKb does not change. Our salt concentration is now 0.230, and our base is now 0.0700. So when you solve for this one, you get a POH equal to 5.26, which gives us a pH of 8.74. And if we look, we added a strong acid. pHs that are lower are more acidic, so that makes sense that this goes down by a small amount. So it doesn't go down all that much. That is the conclusion of lesson 2. So you can go ahead and work on the worksheet for buffering action.